Hello, art nerds. I wanted to share with you what I've been working on the last couple weeks. So I've been doing a ton of fine tuning of Stable Diffusion XL and also LoRa training. So in this quick video, I want to show you the tensor board. I'm going to show you a custom script that I made that speeds up the dataset captioning significantly. And I'll show you my settings and what else? Oh, I'll also show you my data set, what it looks like, the structure, things like that. So here we go. So I'm using Koya SS GUI, which looks like this. It's a lot of buttons. We're doing a LoRa right now. We'll look at the parameters. This is the basic GUI. I have my GUI set up to use a custom dashboard from Weights and Biases. This is a significant upgrade over the tensor board. I highly recommend switching to Weights and Biases. It has all your standard metrics like your loss average and current loss, GPU stats. You can add other stuff, of course. And also, at the top, where'd they go? There they are. You can set a custom prompt in Koya to generate whenever you want. In this case, I'm doing every one epoch. So I'm training a style, and so I have it set up to sample the model every epoch. And also have another prompt. This is really helpful to see how your model is training. Ooh, that's pretty. That's coming along. So to set this up, and it's in parameters, samples, sample prompts. I have these are my prompts that you just saw. I like to do them each one twice. Reason I do that is right here in this parameter. L stands for the CFG scale, which is classifier free guidance. This is essentially how strong your prompt is weighted on the diffusion model. So a higher number will tell the model to follow the prompt more. A lower number will tell the model to follow the prompt less, or have less influence, essentially. So I find that prompting both of these gives me a good idea of how much my fine-tuning settings are affecting the custom LoRa. Basically, if my classifier free looks too much like the higher number, like if these two looked really similar, then I would know that I probably had too strong of settings and the model collapsed and will generate poor results, really artifact. So seeing it so vague like this is a good sign. The actual trainer in the background is running right here. This is just a VS Code instance. This is my Linux terminal, and you can see I'm at 44%, 31,000 total steps. And this is a data set that has like almost 700 images. So this GUI here is talking to this this interface right here, basically, which is this tunnels into my Arch Linux server that's in my office. So that's a quick overview of weights and biases. And you can also overlay other runs. So you can compare runs, which is a cool feature. So moving on, I want to show you a really exciting thing that I made. This is gonna save all of us so much time. So this is my script that essentially speeds up the dataset creation process. So if you've ever made a data set for LoRa or fine tuning, you know that you have to get your images and then you have to caption the image. And an image caption, essentially it just looks like, so here is the dataset folder. This is where you put your images. The log is where the logging metrics go. Model is the model outputs, all the actual checkpoints that you can use for inference later. 15 is the number of repeats. So these are your text, these are your image captions here. And there's the actual images. So your captions are just text descriptions that are comma separated. And these are my images that I'm training that style on. So these have to match perfectly, and you have to make sure that you only have the same file types. Like I've accidentally had a JPEG in there and it causes problems. So don't do that. So anyways, we'll go back to our script. So our script is making all those custom prompts, which is an extremely time-consuming process. So I've set it up to where I upload my data set to my GitHub. So GitHub is just a website for hosting code and small data files. I was able to upload a 700 gigabyte data set, no problem. If you have really large data sets, you're going to exceed the limit for GitHub, but for LoRa's and fine tunes of this size, it's fine. And it's very convenient, it's free. You can host your files, and this is necessary because the script has to read the URL and then send the URL to GPT-4 so that it can retrieve the actual image and look at it and then create your caption. So that's what this script is doing. It's parsing our GitHub URL. It's getting the URLs, and then it's working its magic. It's adding, saving them basically, and then it's reading our custom prompt, which is telling GPT-4, which is going to tell GPT-4 what it needs to do. Then we have our payload, which is basically the API to GPT-4 Vision. Max tokens. This is how many. This is the max that Stable Diffusion XL tokens it can take. So I set it so that GPT-4 doesn't output more than 225 because there would be no point. And then here at the bottom, this is where the user wants to input their actual GitHub, and so you just want to copy this, Command C or Control C, and then you paste it in here, right? So we delete that, put it in, and that's our URL. The prompt file path, we want to input this. And then the caption folders. That's where your captions are going to be placed, your new text files. So I want to show you my custom prompt. I'm still kind of working on this, but since I'm prompting for style, I want the text prompts to see everything in the image that I want to change in the future. So since I'm training a style, I don't want my style to be in the prompt. I just want all the objects, the subjects, the lighting, things like that, because I'm trying to get a painterly brushstroke effect out of this LoRa. So I like to do a natural language prompting style. You can also tell GPT-4 to do like Dan Burrow style tags. Either way works just fine. It just depends on how you like to prompt. I prefer natural language. I like the art more that comes out of it, but that's just a personal preference. So I tell it it's a genius, tell it what it's doing, and I kind of give it as a example. So that is our custom prompt. So that's pretty much a rundown of the script. We'll go ahead and run it. So I'm using Conda as my virtual environment and VS inside of my VS Code. Then we just tell it to run the file, which is Python caption AI, hit enter. And I have it print outputs, which is fetching URL, and then it reads the custom prompt, constructing the payload for the API, and confirming that the payload, it's just received response for payload, and we're done. It is already saved to a file. So we'll check out our file, and we'll look at 210, and we'll compare it to the actual 210. So it's a pretty landscape in this case. And so we got twilight, wide angle lens, expansive shot, captures a dynamic mountain range with vivid sunset, jagged peaks silhouette against a fiery sky, blah 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 blah. Awesome. So if you had to do this manually, type this all in for 700 images, it would take a long time. Even with the software, like the dataset taggers that I've tried, it's still like such a tedious task. So to have this automated is awesome. Like I can't. This is gonna save me so much time. It might take me 3 days or maybe a week to do 700 images. I don't know. It would, and it's just mind-numbing, boring stuff. So to have this done in such an effective way is awesome. Obviously, for the system prompt, if you're gonna do a style versus a character versus an object, it's gonna be different prompting strategy. For object, depending on the object, you probably don't even really need to do captions at all. If it's something that already exists or something similar that exists, you could just use a trigger word and add that to all of the text files, and that would be simple. For a character, you might get away with it not doing all this, but you might not. It just depends on your needs. If it's just a simple quick LoRa, probably be fine, but something more advanced you need to use over and over again, like a fine-tuned model, you're gonna want to have a better system prompt. Okay, so that was our script. We'll go ahead and take a look at some of the some of the settings that I like to run. For batch size, I find that 8 or 10 is fine. Even though I have a high performance GPU, I have an A6000. It could fit 28 to 32 depending on the dataset size. I find that since I'm running noise offset, that I get better results because I'm running the noise offset 357, that I get a better result with less, if I don't use all the RAM, basically. If I don't, run it all the way to like 47. Right now I'm running, it's at 32 gigabytes, so there's still plenty of room on the GPU for the noise offset to run. I like to run 30 epochs, save every 1 epoch. I like to run BF16. Cache latence, saves a lot of RAM. Of course, seed 1337. I am not using this learning rate schedule. I'm using cosine annealing learning rate. And I'm setting that in the additional parameters because it's not available in the settings. For the optimizer, I'm using the Prodigy Adaptive Learning Rate Optimizer. I find this gives me much better results than the de-adaptation optimizer. And for LoRa's, it's even better than running like Atom or any of the optimizers that other optimizers that I've tried. It does take some tweaking on the decay and also the press the wrong button. And the yeah, on the weight decay. I'm finding around. It's kind of counterintuitive on the weight decay. 0.35 it would actually be stronger with a Prodigy versus 4.5 would be less strong, which is kind of opposite if you have like a fixed learning rate using a more traditional optimizer like Atom 8-bit or Atom W. So that's an interesting, they're like inversely proportional. I'm not running a learning rate warm-up because according to the Prodigy documentation it doesn't play nice. So that's why I'm running safeguard warm-up true. For resolution 1024 by 1024, pretty standard. I am enabling bucketing because I have a lot of non-square images, so that's a really nice feature. You set the bucket settings for your individual data set. Mine's all under those settings, of course. Everything's 1 for the learning rates because we're using a adaptive learning rate. For network rank and alpha, I prefer 256 by 256. A lot of people run different settings, but this is what I have found gives me the best results. The LoRa is heavier, so that might be a downside, but I've seen some people run 1 and 256, but I find that this gives me better results, at least for my prompt strategy and dataset style, creation style. Tmax is kind of weird. Like in the docs, it seems like it's supposed to be the steps, but I get much better results when I keep it near my epoch, which is usually 30, so it's voodoo there. Network train unit only. This is specifically for SDXL because it has 2 text encoders. It has the original clip and then the big G clip, which do not like to be trained, at least not, I haven't figured out a way to do it yet very well with Koya. So I just only train the unit and it seems to still work just fine. Clip skip, for SDXL, that 1 is fine. Keep number of tokens. If you have like a special activation token, you can run like 1 or 2 and that'll save the token in the text file, the first token essentially, if that makes sense. Like caption tools, right? So the caption, so keep number, so if I set it to 1, it'll keep Twilight. So if you have an activation word, like some people will say, backgrounds or the name of a person. Let's say it's Danny, right? Danny in wide angle, blah, blah, blah. So that can be useful if you want to prompt that way. I personally don't do that. I just say in the style of, and then I put the name of the LoRa, and it works just fine. But either way, works in my experience. Creating checkpointing, shuffle captions. The captions are obviously. I'm getting tired here. Sorry. So, shuffle captions for our captions. It will at each comma will shuffle these around. The reason you want to do this is because generally a model is influenced more by the end of a prompt and the beginning of a prompt. So if you're fine-tuning, you'll get better results if you shuffle the captions as it goes through the machine each time. Don't upscale unless you want to. I think we about covered it. Noise offset. That gives better results in my testing. And here's where you enter the weights and bias stuff. So yeah, that covers it all. If you have any questions, feel free to ask. Any comments? If you think I suck, that's great. Feel free to let me know. And I hope this sparks some creative energy. Fine-tuning is an art in itself. I am just an artist. I taught myself this stuff on my own just by, taking free online courses over the years and studying Python and lots of YouTube videos. And so, anybody can do this stuff, and there isn't necessarily a set right or wrong way to do it. So, there's, people who have experience in other domains have an opportunity to contribute, which is really awesome. So don't be afraid, dive in, have fun, and I can't wait to see what you create. Alright, Artners, hope you have a wonderful time playing with these cool toys, with these cool art tools. Bye.